Okay, friends, here we are. We want to talk of that physics, paper one. I have done it already from the previous video that I recorded. I think there was no video that was showing, so you can look at this. So the first question, you only subtract 0.2, you get 0.29 millimeters. Then second question, you estimate the height of the tree using the height of one student. So you measure the height of a student, then you measure the length of the shadow of a student, then you measure the length of the tree, then using that formula, you are going to have the height of the tree as symbols like that. Then we are having the building block placed on a blank code supported by two pivots here. So what you do here is supposed to give the tension of forces. Tension of forces are there. You can see where the block is, and the tension of forces, how I have placed them in that direction. Then question number 7, explain why spanner B will require less force when loosening the nut. The question is trying to test a learner on whether he understands those factors affect the turning effect of a force, and that is one of them being perpendicular distance. So B has a longer distance, that is longer handle, and therefore longer distance, perpendicular distance, and whenever there is longer perpendicular distance, then it uses less force. Question 8, why do you think that the ball is said to be unstable, is in an unstable equilibrium? Is because when you push the ball slightly, what happens with the ball, the line of the ball where there is a center of gravity, the gravity becomes unstable, and the center of gravity becomes unstable, and therefore in fact the COG increases, and therefore you see the ball falling out. That's why it is unstable. A student is used to calibrate a spring balance using the weight. Other than spring balance and mass, you are supposed to give other apparatus a student can use. That student can use a meter rule. At the same time, he or she can use a graph paper. Question number 10. It is observed that a vehicle traveling a dusty road leaves a trail of dust rising high above the ground. Explain the observation. So these are questions that are coming from fluid flow. So the air which is below the vehicle, of course, increases. The fluid of the air increases, the fluid velocity increases, and that causes air under that particular vehicle to reduce. And because of the difference in pressure, atmospheric pressure now lifts up the dust above the ground. Then we have number 11, an object moving with an initial velocity of 3 meters per second uniformly decelerated to a stop after moving through a distance of 10 meters. You are supposed to determine the acceleration. So use the formula that applies the equation, v squared is equals to u squared plus 2as. So you substitute our v is 0, initial is 3, 2 times acceleration times displacement, which is 10. Then when you substitute up, you come out with acceleration of negative 45 meters per second squared. A student placed a coin on a smooth cardboard, which has a top or empty glass beaker. The cardboard was then suddenly pulled horizontally away from the beaker. State and explain the observation made. Of course, the coin will fall in the empty glass beaker. The reason is because of the inertia motion that makes the coin to tend to remain in its state. Now, number 13, state one source of non-renewable. Sources like fossils, biogas, dry cell, nuclear energy. Explain why a person trapped inside a smoke-filled room advised to crawl along the floor towards the exit. Remember, if you crawl along the floor is whereby there is less dense of dust particles. You not say feel like crying along there. So what I'm saying, the smoke, when heated, those particles become less dense and they move up. They are lifted up. So smoke is less dense than air, hence rises up, becomes light when heated. Then page 6, we having state the meaning of the term specific heat of capacity. Is simply the amount or the quantity of heat required to raise a temperature of a unit mass just by 1 Kelvin of a substance. Then number 2, a student observed when an ice cube is placed in water, it melts. Why do you think the ice melts when it's placed in water? It's because water provides heat, and that is specific latent specific heat of water. So when this heat is provided, it overcomes the latent heat of fusion of the ice, and therefore the ice melts. State 2 ways in which melting point of ice can be reduced. So the melting of the ice can be reduced. There are two factors, either pressure or impurities. To reduce the melting point, we have to increase the temperature, the pressure, and also as well add some impurities. A block of ice zero is applied with 2000 joules of heat. Determine the mass of water that will melt. Remember, our formula is the quantity of heat you supplied is the same as take the mass multiplied by the latent heat of fusion for the ice in this case. So we have Q, we have 2000, mass we don't have it, then we have the latent heat of fusion as 3.36 times 10 to power 5. Then you substitute in, then you calculate, you come out with 5.952 times 10 to power negative 3 kgs. A student, 25 grams of hot water at 50 degrees Celsius with 75 grams of cold water at 20. Determine the final temperature, right? So heat loss is heat gained. So the heat is lost in the hot water and the heat is gained in cold water. So you use 25 over 1,000 times 42,000. Remember, they are giving you the specific heat. This year, they were given as 42,000. Usually it becomes 4,200, but you use what they are given there. So if you use that one, substitute it very well, you end up having 27.5 degrees Celsius. Student of a certain school want to verify Boy's law. Okay. Question 1. State two apparatus can student be used to should need. Number 1, because of Boy's law, pressure is kept constant, then this person must need a pressure gauge to measure pressure. He or she must need measuring scale to measure maybe the volume of the air. He or she must need air pump. Those are the some of the apparatus. State 1 quantity kept constant. So temperature must be kept constant, of course, mass. Apparatus was used to investigate the rate of division of two gases, A and B. Okay. So if you look at it, identify the gas that they've used first. The one which traveling a longer distance is the one that they've used first, and that is gas A. If you look at that experiment. State 1 way of increase the rate of division. It is only by increasing temperature. When you increase temperature, remember, you are increasing the collisions of the particles, and they become more light to move very fast. Then part C, Roman 1, explain Charles' law using kinetic theory of gases. So you have to talk of kinetic theory, how those gases collide. And this one you have to use temperatures. When temperatures increase, what happens? The particles gain kinetic energy, and therefore they move very fast and start colliding per unit area with the walls of that particular container. And that's when we increase the rate of change in momentum. There's a question here that is asking a question of calculation where a pressure is kept constant. That is, of course, Charles' law. The volume is given 20, temperature is 19. The volume of mass when the temperature increases to 24, right? So V1 over T1 is equals to V2 over T2. That's the formula. You substitute in, you end up having 20.34 cubic centimeters. Now, this is a question from beamform circular motion, speed of a circular path of radius r, and you are given that the object moves from point A to point B in a time t seconds. Now, indicate on the diagram the angular displacement, that is theta. Theta is there, up there as the way I've indicated. And linear displacement is just the distance that it covers along the circular path. It is also shown there. State the Archimedes principle. Archimedes principle is when the body is fully or partially immersed or submerged in a fluid. It experiences, of course, an upward force that is also is equal to the weight of the fluid displaced. Now, you are given some apparatus here to verify Archimedes principle. You ask the first question, describe how the mass of water displaced may be measured using this apparatus. So what you do, you use, you record the volume of water in a container using a measuring cylinder. Then come and immerse some solid metal in that water and record the new volume, subtract, then get the volume, determine the volume of water displaced. Then if that is the volume of the water displaced, you are able to find the mass by taking the formula that volume times density, you have your mass. Archimedes principle, how do we verify Archimedes principle here? The first thing is determine the weight of displaced water, then determine the apparent weight of the solid metal. Then how do you find the apparent weight? You take the weight of the air, then you subtract the weight in the water. Then that's how you come and verify indeed Archimedes principle is verified. One way of reducing surface tension in liquids, you only add impurities or increase temperature. The last part, it is observed that when a certain metal of placed water, when you submerged different liquids, glycerin and water, there was some difference in submission or in floating of that object. Here you talk of density of the two fluids. So the density of glycerin is very, very great than that of water. And therefore the body will be displaced more in water than in glycerin. Then number 19, a stone and a piece of paper released from the same height of vacuum. Keyword is vacuum. Remember, in a vacuum, there is no force of gravity. So there will be no air resistance. So both will reach at the same ground because there is no force of gravity and therefore there will be no air resistance. A car of mass 1560 traveling at a velocity of 25 is brought to rest by a constant force of 3000 newtons. Determine the change in momentum. Momentum is a product between mass and volume. So you have final and initial. Final and initial. So initial is 25 and final is 0. So you're having 0 and 25. If you substitute there, you end up getting minus 39,000 Newton second. Time it takes for a car to come to rest. It's very simple. Take momentum, change in momentum is equals to Ft. Already we have the momentum as negative 39,000. So we have mass, the force, which was 3,000. So you substitute, you get your time as 13 seconds. Last part. Jane measured the length of the palm using your hand, palm hand. So you're supposed to describe the palm length may be used, how it may be used to estimate the length of the laboratory table. So the first thing, you measure or you count the number of palms in the length, transferring the palm length along the table. So from there, to find the length of the table is take the number of palms multiplied by 18.7. Explain why estimated length of laboratory table is not accurate. There is a parallax error whereby a student was unable to transfer exact length due to shifting in position and complete the palm length. Also, it can be in the case of inaccuracy in measuring the length of the palm. That is the end of the topic, the paper, paper 1, Kcse 2025. Subscribe, like it, and share to your friends. Until next time, we're having paper 2.